We looked at uncertainties already in the context of the feedbacks, information for adaptation, especially at local scales. The question, of course, for social scientists is how to deal with uncertainty, and the terminology uncertainty monster is used especially by people like Judy Curry, and then the organizations or groups like Skeptical Science, which try to answer people's attempts to let's say misrepresent science or interpret it in a different way. They respond quickly to say what is wrong in the way the portrayal of model results as uncertain can be done wrongly, let's say. Okay, I hope it's clear what I said. Okay, so is there anything like safe uncertainty? Often it in terms of decisions, it comes down to what is called avoid the unmanageable and manage the unavoidable. Obviously easier said than done, but this is what we are talking about. We are talking about models able to capture the historic trends with their range based on various model uncertainties and initialization issues and forcing issues in terms of volcanoes, solar activity, greenhouse gases, land use change, etc., biophysical, biogeochemical feedbacks, and so on. And then you get into projections where you have all your RCPs with multiple models running 32, 42, and so on for various reasons, and they all use the uncertainties the scenario parameters in terms of renewable energy evolution, technologies, land use, population, and so on. So this is quite a broad range, going from about 0.5 degrees to 2.5 degrees by 2050. So if you are trying to remain below 2 degrees with 66% probability, then you have to see what are the issues to be dealt with in terms of uncertainty. This is another way to look at this. Is from Skeptical Science in response to Judy's article on her blog post, I think. This is looking at various models and looking at contributions to the warming over the historic period past 50 to 65 years in terms of greenhouse gases, sulfur dioxide, solar forcing, solar activity, volcanic forcing, El Nino contribution. When El Nino happens, there is a mini global warming because it releases the heat that has been stored in the ocean. Human total, so that is non-greenhouse gas activities that contribute, and natural variability. Okay, so you can see El Nino there as well. So the point again is that they do agree on signs most of the time, except here for different model having different sign. But the idea is that models can be different, and the question is, how much does it matter if one model is giving a much higher contribution of percentage of GHGs and humans, then what exactly does it mean in this plume, for example? Okay, and the idea from Skeptical Science is Decran Marsupial calls it not an uncertainty monster as an unfriendly thing to be scared about, but it's an uncertainty Ewok, which is the Star Wars character, because while there are of course climate uncertainties, some of the which are quite substantial, science and statistics have developed and refined sensible approaches to dealing with them, and they are nothing to be scared of. As long as you know them, you quantified them, right? Like Donald Rumsfeld used to say, there are known unknowns and there are unknown unknowns, and so on and so forth. The existence of significant uncertainties does not mean we don't know anything or that no conclusions can be drawn. We understand the main drivers of the climate reasonably well, and the climatologists and the Intergovernmental Panel on Climate Change consistently take the remaining uncertainties into account when drawing conclusions or issuing guidances, summary for executive summary for policymakers. So just to make sure you know, Ewoks are a fictional species of small furry mammaloid bipeds that appear in the Star Wars universe. They inhabit the forest moon of Endor and live in various arboreal huts and their other simple dwellings. Okay. We also have to worry about uncertainty when we worry about climate adaptation. As we already talked about before in this course, there are types of adaptations going from capacity building, management and planning, practice and behavior, information, all out to technology. The main thing to remember is that adaptation almost always is local, even though some of these technology financing issues and capacity building can be global activities with global scope, especially information. That uncertainty has to be able to deal with adaptation needs, adaptation capacities, socioeconomic vulnerabilities, extreme events, expected sea level rise, etc. at local level. So in that sense, the most important conclusions from quantitative modeling often tend to be qualitative. You remember that dangerous anthropogenic interference we looked at in terms of the unique system, extreme events, distribution and so on, where we had a scale that went from white to red based on the warming levels. So that's kind of a qualitative depiction of the risk, right? So Dawson et al. Argued that most popular frameworks for modeling the impact of climate change on biodiversity are both spuriously precise and potentially misleading because they do not take into account all of the available evidence, much of it qualitative or semi-qualitative, about how species have actually responded to climate changes in the past, which would show that their assumptions are flawed. So models like to be quantitative. They have to represent everything statistically, empirically, or from first principles, and then allow feedbacks to have emergent solutions. But the empirical system also relies on numbers and not translating qualitative and semi-qualitative information into parameterizations. Secondly, although they presume to inform conservation policy, they start in the wrong place with a mechanistic prediction instead of first posing the important practical questions like what conservation measures are likely to be effective in a changing climate. So they start by saying this kind of species will have this much impact with this much warming and this much precipitation change, or broadly saying this will be unsuitable for this crop or this forest, etc. So that's a very different way of starting than by asking the question first and then using the model to answer those questions. And then the models ask what types of information exist or required to answer it. Sorry about that, the doorbell rang. Nonetheless, so how to take these quantitative models and their qualitative outcomes and use them for things that are more complex, like biodiversity and conservation, or even cultural values and so on. Okay, so maybe I should continue for another minute despite the interference. Nevertheless, the power and realism of Earth system model have their limits, and there are some areas that we argue that scientists should avoid. Okay, that's a pretty powerful statement. The first and most obvious of these is the quantification of practically unquantifiable things such as the value of biodiversity. Another is attempting to predict phenomena that lack any useful predictive framework. For example, major geopolitical events or technological breakthroughs may well have causal influence on a future outcome, but there is no known mechanism that shapes their dynamics. Okay. A further category is situation where prediction would be unhelpful even if it were plausible or possible. For example, using models to try to predict which policies will be adopted is a futile direction if what is needed is to use the model output to inform a decision-making process. Okay, there are differences in providing input to policy making based on what we know from the physics, biogeochemical, biophysical feedbacks, Earth system perspective, including socioeconomic impacts and feedbacks. But that doesn't translate to saying that which policy will be adopted is going to be able to be concluded from these Earth system models. Where there are questions of human agency, a more useful approach is deliberately to retain that part of the process outside the model black box. Okay, agency here means the autonomy and the capability to act, let's say, on the climate change problem or on adaptation that is being attempted with this Earth system model outputs. Okay, so obviously complicated issues, but this is what it comes down to in terms of translating Earth system models to decisions and policies, that the social dimensions and the way social decisions and socioeconomics and human systems work has to really be served properly by these Earth system models.